Thank you, Nick. I can see I'm going to have my work cut out. It's a warm day. You've had a nice lunch in the sun. And I think we're under pressure on time. So I'll spend the next 15 minutes talking about an area of great excitement and great activity, an area where I think the UK has true global leadership, and that's the area of fuel cell electric vehicle technology. A good starting point is to go to the technology roadmap that Neville has just mentioned. And in a sense, you could say that I'm presenting the bookend presentation here, because everyone has alluded to fuel cell technology being long-term and strategic and words like that. I'm talking about the green area of the chart in the top right-hand corner. But I would also say that whereas this chart shows fuel cell technology coming to market round about the 2020 timeframe, I think there's growing confidence and indeed a number of public statements being made by certain OEMs to confirm that fuel cell cars will become commercially available in certain markets in the world as early as 2015. So this is a coming technology that is just around the corner. It isn't as far away as you might think. Now, it's interesting to look at the factors that are driving this, and in particular to consider the growing role of hydrogen as an enabler to decarbonisation of road transport. Today, it's not at all difficult to find forecasts in the public domain talking about the trend to ramping up of fuel cell car sales volumes over the period 2020, 2030 to 2040. Commonplace now to find forecasts like that, and there's a thread of commonality that runs through most of the information that you can find. Equally, it's not unusual to find press commentary that talks about the corresponding rollout activities to actually put in place the infrastructure to provide hydrogen at the roadside to refill the cars. Now today, I think it's fair to say that in Europe, we would probably think of Germany as being out of the blocks and slightly ahead of the UK. But there's a very impressive UK initiative that I'll talk about in a minute that is addressing that issue and has the potential to put the UK in the lead. It's important also to understand that behind this, there's a growing appreciation of the role that hydrogen has as a major energy vector in the future and how that impacts on transport. So at the bottom of the chart here, you can see various ways in which we source hydrogen. We can source it from natural substances, from natural gas and biogas. We have it available today as a byproduct of existing chemical and petrochemical industrial processes. And we can generate it through electrolysis. And if we use renewables to power the electrolysis, then we've got a true zero carbon fuel. And that fuel, that hydrogen, can also be stored. So it plays very well to the renewable energy sector. You can generate your electrical power as and when the wind is blowing or the sun is shining, but you can store it in grid scale to use it later on. And if the hydrogen is being generated and if it's being produced, then it's available not just to support industry and domestic applications, but it's also going to be available for road transport. So with that as a backdrop, let's spend just a couple of slides looking at some of the advantages of fuel cell vehicles that will use this technology. I happen to think that this is a really exciting area. I think we're going to have some very impressive vehicles coming to market that are not only efficient and exhibit very low levels of carbon emissions, but they're going to be interesting to drive and very high performance. Why do I say that? Well, first of all, the cars themselves are going to be zero CO2 at the point of use. And if, as I've just explained, we use renewables to generate the hydrogen, then the wheel-to-well, if I can use that in this context, the well-to-wheel emissions of the vehicle will also be zero. And on top of that, we have the advantages that we have come to expect from conventional or battery electric vehicles. Those include great, strong acceleration and very high levels of refinement, which lead also to low levels of occupant fatigue. But on top of that, fuel cell electric vehicles can address some of the limitations of today's battery electric vehicles. Fuel cell vehicles will provide a normal range of driving. So the range anxiety that people talk about so much with battery electric vehicles will be dissipated. 300 miles, 400 miles, 400 miles plus, very realistic. And in addition to that, when you come to recharge or refill your hydrogen fuel cell vehicle, it will be a conventional process, just as in today when you go to a gasoline station to refill with petrol or diesel. 2-3 minutes, you're refilled, you're back on the road. So all of the advantages that we like from battery electric vehicles, and potentially with none of the drawbacks. But I just want to touch on this issue about battery electric vehicles and fuel cell vehicles. I want to stress the point that these technologies are not necessarily competitive, but rather they are complementary. I think the economics as we see them at the moment suggest that battery electric vehicles might be best suited to low mileage usage. And I've just explained that fuel cell vehicles won't have that economic drawback. But these two technologies should coexist. They will use common components and powertrain platforms, and we should look to both of these technologies growing in parallel over future years. So to summarize this section, essentially we have a range of fuel cell electric transport that's ready to go, so long as the infrastructure to refill them with hydrogen is available. That leads me on to a very important UK initiative, UK H2 Mobility. This is a program that started in January of this year. It's a 2-year program running to the end of 2013, and there is a report to British government due at the end of this year. It's an excellent example of government and industry collaborating. On the industry side, companies who you might regard as competitors are collaborating around the table, very much with the focus of understanding what it will take to make the UK a leading country for the early deployment of fuel cell vehicles. The work of the collaborative program is focused very much on planning the rollout of the infrastructure and the possibilities for sales and ramp up of fuel cell vehicles to go with it. It's this perennial chicken and egg situation. The car makers need to know that the infrastructure will be in place. The infrastructure providers need to know that the cars will be there if they invest in the infrastructure. This collaboration is aimed at addressing that. The focus is, the work is actually being carried out in 4 work streams, and the output of the work is to provide an evidence-based perspective on how we can go forward, to create an implementation plan and a business plan that is both credible and investable in the shortest possible time. The work of the group is confidential, but we have passed some intermediate milestones, and I can tell you that so far we are on track to report at the end of the year, and the prospects are looking very positive. Finally, just let me say a few words about expertise and excellence in the UK, which is what we're here to talk about today. On this slide, I'm not going to go through the various organisations that I've listed, but the point I want to make is that in the UK, we have a range of organisations ranging from academia through to industry who are world-leading in this area. This covers the generation of hydrogen through to the fuel cell technology that will be embedded in vehicles themselves. And it covers fundamental research, engineering development, and the industrialization and commercialization of the technology in the products. And bear with me on this. Of course, I happen to believe that one of the leading players, and as Nick said, one of the leading global players in this field, is my company, Intelligent Energy. Our job, essentially, is to develop technology, fuel cell technology, bring it to market, and make it easy for the OEMs to use fuel cells and get into that growing sector of business. Let me pick on two examples to show progress and relevance. In the middle there, I've highlighted some of our two-wheel activity. It's well known that we have a long-standing relationship with Suzuki, which has produced the Suzuki Bergman fuel cell scooter. We've gone further than that. We've actually created a joint venture business with Suzuki, which is aimed at designing, manufacturing, and selling fuel cell systems, not just for Suzuki's use, but also to make that technology available to other third parties. Tangible evidence of commercialization just around the corner. And then finally, and I include this really as relevance to last week and this week, we have also been involved in a project which is evidenced with a fleet of 5 fuel cell taxis, which are pounding the streets of London as we talk, transporting VIP visitors on behalf of GLA, the Greater London Authority, to and from Olympic venues. A great showcase not only for my company, but also for fuel cell technology as well. Thank you.